Hey everyone, Stephen Hack here with Career Watch, where we help you with your career search. We noticed that there aren't very many videos on nuclear engineering out on the web. So today we are interviewing Mack Cullison. Mack is getting his PhD in nuclear engineering at Oregon State University. So in this video, he's going to go over how he got into nuclear engineering, what it's like, and why to consider the field. Let's get started. So I got Mack Cullison here. He's getting a PhD in nuclear engineering. Yeah, tell me about how you became a nuclear engineer, like what drove you to become a nuclear engineer, and actually where did you just start? Just give us some background on where you started.
Yeah, so back in high school, I graduated a year early and I joined the Army National Guard in Oregon. And then went to Fort Benning, basic training, became a carpenter and went to Mississippi
Wow.
and picked up masonry as well. And then I deployed to Kuwait and then I did some like mission in Baghdad, Iraq actually. And then when I was there, I did a lot of stupid stuff being in the Army, you could imagine. And so I wanted to come back to home and do engineering because I grew up in a junkyard. And so I didn't know there's actually more than one type of engineering. So I looked at just which was the highest paying. And here in
Mhm.
Oregon State, it was nuclear engineering. And it turned out to be so much more. Like I didn't know like how much potential there was in it. So normally engineers like go like mechanical engineering or civil engineering
Right.
or like or construction engineering management or bioengineering or chemical engineering, and nuclear engineering is pretty niche, and it's really difficult as you can imagine,
Oh yeah.
but we learn so much. And I think radiation is like one part of it, but also the engineering, we get pretty much everything that mechanical engineers do as well.
Mhm.
So there's just so much flexibility in what we do. And
Right. Mhm.
yeah, four years later graduated, and now I'm doing my PhD program.
So you did like GI Bill kind of thing. You did the Army. You did like 5 to 10 years. Came out. Used the GI Bill to do like a 4-year college degree in Oregon. And then did you go straight to master's, or did you try and go straight to PhD from undergrad?
So with the Oregon Army National Guard, so you only serve a weekend a month, but I did a deployment, so I did a whole year, and you only get 50% of the GI Bill, and then I did ROTC to kind of make up the rest, and then I ended up getting out of ROTC, and then I went straight from my bachelor's to a PhD program because I'm with a new instructor, and he does material science specifically, like nuclear material science. Our college picked him up, and it's a really exciting field because we're limited by material science because you can only run a reactor so hot before the materials start failing, or only push the material so hot or so hard. So there's a lot of interest in material science, and so I chose that to try and further the science. If I made any progress, it would be immediately seen.
So like, yeah, like when I guess you'd be on a team, right? Like there'd be someone focused on nuclear engineering. There'd be like a mechanical engineer on the team, depending on the industry, depending on the job. But
Mm-hmm.
it's like it seems like there's so much collaboration with engineering jobs where you're on a team and there's a nuclear guy, a mechanical guy. There's a I mean, that's a really niche field as well, materials
Mm-hmm.
engineering. Yeah, there's not so many jobs. It's very, very niche. But yeah, it's really interesting. So what are you interested in doing with your nuclear engineering degree?
So there's a lot I'm interested in. So I want to become a professor personally,
Mhm.
but I wouldn't mind going to like a research facility. So like all the national labs in the United States were kind of uh, homegrown from nuclear engineering, if you could imagine. You know, Oak Ridge National Labs, Pacific Northwest National Labs, there's Idaho National Labs. So there's all kinds of national labs. I think the most impact I could do is to become a professor and then just teach the science really well and really market our field.
Right.
And there's so much more. So like from a career side, like there's gonna be a lot of jobs in it because there's some like 20 or 30 startup companies working just from the United States on the generation 4 nuclear reactors.
Hmm.
So for example, you have New Scale out of Oregon, which is based on safety, like just strictly safety. Like the CEO of that company was really involved with the 3 Mile Island. I don't know if you've ever heard of that.
Yeah, the nuclear act. It wasn't a huge deal. It wasn't like Chernobyl. It wasn't like
Yeah.
Fukushima. Just like level 1 incident.
Hmm.
No one died, right, in 3 Mile Island.
No, not at all. I don't even think there's radiation release. So all that happened was like a pressure relief valve got stuck open, and there was no like indicator if they got it closed or not. So that led to some meltdown, but it was all contained. And our industry really hurt from that
Yeah.
because, as you can guess, like oil propaganda, like just jumped on that super
Hmm.
quick. And so we hurt from that. And Jose Reyes from New Scale was really involved with that. And now they're looking at, or Westinghouse designed a new reactor, which they're building in Vogtle, Georgia, which is the AP1000, which when it fails, it just relies on buoyancy of water. So you're relying on gravity rather than pumps.
Okay. Yeah.
And so,
So that was like in the 70s, right? That was 3 Mile Island was in the 70s, and there was a huge political movement that was very anti-nuclear energy. And yeah, like that really, there was not very many nuclear power plants built since. I know there's a new nuclear power plant being built in Georgia with 2 new reactors, like Plant Vogel, or I don't even know how to say that word, Plant Vogel or something like that.
Yeah.
And that should be coming online in the next couple of years. But yeah, one of the big issues is they're thinking about closing a lot of different reactors, the utility companies. A lot of people seem to think that nuclear power plants are government managed, but it's really utility companies that have like a license to operate these nuclear power plants. So yeah, there's definitely some challenges ahead, but yeah, we'll see what happens.
Right.
But then there's also like the healthcare side of nuclear energy. And are some of your classmates going to be going into that? Are they trying to become, what do they call it? Like
radiation health
nuclear engineers that are / medical physicists. So a couple of your classmates are kind of interested in that.
Yeah. So we take a lot of courses with them. They're called RHPs, or radiation health physicists. So they all actually look at like, you take an X-ray, they measure how much dose you get. So that's why you wear like a lead jacket when you go and take an X-ray. So every hospital has a radiation health physicist that's working with like a radiologist or something to determine how much a dose a patient is specifically getting.
Interesting, yeah. And I'm sure there's like a lot of research and development in that area as well.
Oh yeah, yeah. So I work in an office with a guy that is a radio pharmacist, and so right, wow. You can imagine the pipeline from an RHP into the medical field. There's like radiologists, they make like $400,000 a year, so that's a really good like pipeline to feed that.
Yeah, I imagine. What else do I got? Let's see. Oh yeah, did you ever consider, because you were in the Army, basically there's a lot of opportunities for nuclear engineers to work on nuclear submarines and pretty much all the aircraft carriers are nuclear powered. All the submarines in America's fleet are nuclear powered. There's actually I have family members that have done that. They have done Navy ROTC, and yeah, they just work on a submarine for as long as they want, I suppose.
Right.
Yeah. Was that ever any? Go ahead.
Yeah. So one thing you want to think about going through like an NSE program, we're pretty like engineering is pretty male dominated, is what you would think. But I would argue like my experience with nuclear engineering is it's a really, really, really diverse program. Like we have old people in there, young people. We have like 40% women. There's just so much diversity. And so, yeah, we get a lot of Navy people that come back from operating nuclear submarines, and then they want to get a degree, even though they have all the knowledge. They want to get a degree in it and then go back and like teach or something like that, or be a senior operator. So most people don't know this, but you only need a high school degree to operate a nuclear reactor. So
you just have to get licensed. That's right. There's another occupation where you get licensed by a state, I guess, to become what is it, nuclear technician, maybe? That's the
It's a
title?
nuclear reactor operator.
Nuclear reactor operator.
But you
Okay.
need a degree to become a senior reactor operator,
Okay.
which is like you're the go-to person when operators are kind of struggling. And so for the Navy program, like there's a really good program for Navy people, and they do their degree in 3 years. They get paid a lot, like $4,000 a month, just to go to school for. That's. I got a kitty. Yeah, you
Nice.
can edit that out. But yeah, so there's good programs. That's called NUPOC.
NUPOC,
And
that's the Navy
Navy
nuclear
underwater
technician or
something.
nuclear.
Yeah.
Mhm.
But pretty much they give you a really fat bonus at the end of your school. They give you a good position, and yeah, they go into the Navy for as long as they want. I think it's 3 years to just get that commitment, and then
And they come out and they can use GI Bill if they want. You said it pays 50% now? It doesn't pay everything?
so that depends on how long you serve. So I did a year of active
okay.
duty. So because the rest of my time I did National Guard. And in the Army, there's career opportunities as well. So you got like the CBRN, which is the chemical, biological, radiological, and nuclear. So that's two that nuclear engineers can work at. And then there's also the nuclear weapons side of things. But I'm a big peace person, so I don't like nukes.
Hopefully, most people are.
Yeah, and I think it's really interesting, like talking to people and like climate activists and stuff that it doesn't seem to be that prevalent, but a lot of people are more concerned with the economics of nuclear energy, and that's really interesting to kind of see with climate change is we're driving towards fossil-free energies, right? And what the push is for like wind energy and solar energy. However, if we look at like Germany that got rid of their nuclear power plants, they're having to rely more on like France to provide the power. And just the other day, France provided 112% of their own grid with green energy, and 90% of their grid was powered with nuclear energy. And I think the rest of the world will see that and kind of lean towards it, especially with this next generation of reactors. Improve safety, economics, different materials. It's just like bringing all the innovation that we've been lacking for 50 years about, and they're going to hit hard with it. Like Bill Gates is invested in it.
Yeah. I saw that Netflix series. I think it's like episode 2 or 3 where he talks a lot about nuclear energy, and he funded, I don't know what the startup is. I'm sure you know what it is, but he funded a startup, and he was just going to build nuclear reactors in China. And then it got shut down or something because of the Trump administration or something like that. I forget, but it's a pretty good episode to watch and get informed about what's going on.
What episode from what?
I think it's called Bill's Brain. It's on Netflix.
Bill's Brain. Okay.
So it goes over Bill Gates, and every episode's something different that he's doing right now. He's trying to get rid of polio. That's one episode. One of the episodes is about toilets in Africa and sanitation. And then there's a third one that's about nuclear energy. And he's very pro nuclear energy.
Yeah. It's really exciting. It's a very promising future for our field. And I know you did a video on like the kind of like the job forecast. And after Fukushima, like there was a sudden drop in jobs, but like I think that was actually like a trigger for things like NuScale and these startup companies to start reevaluating, like, all of our reactors are on their like 40-year license limit. And they're now, some of them are re-upping for another 20 years, and some of them even out to 40 more years. So an 80-year total. Right. Considering that. And that's why I got into, some of the research projects are like, is it safe to push these things out? And it looks really strong. And there's a lot of drive to keep the nuclear reactors online as well, because it's just so much carbon-free energy.
It is, and it can operate at any time of the day. Wind and solar, they're they're intermittent.
Mm-hmm.
I think there was some, I forget what it was, but I was reading about how it was like late at night and there was a power outage, and it was like the nuclear power plants that came on and made sure everyone still had power. And you just
Mm-hmm.
can't really have that dependence on solar and wind, at least at this point. And, battery technology is just not there yet. I don't
Mm-hmm.
know if it'll ever be there, but I don't know. What do you, maybe you know a little bit about that. I'm not sure, but yeah, I mean, nuclear, um, I think we'll see what happens. I hope it takes off more. I hope more nuclear power plants are built. Maybe like once this power plant that comes up in Georgia, maybe it'll prove the concept that it's safe, it's working, it's providing.
Mm-hmm.
The other issue is natural gas, right? Like natural gas is extremely cheap. There's like a lot of natural gas in the United States, and it's making it harder on nuclear.
Mm-hmm.
It's
Yeah, I
like
see.
nuclear is getting hit on both sides because natural gas is so cheap, and they're providing subsidies for wind and solar.
Mm-hmm.
So
Yeah,
it's like, yeah,
natural gas is a really strong competitor, like especially for America now with like fracking technology and stuff, where we have 100-year supply of natural gas for
yeah,
just from America to Americans.
mm-hmm.
And these, yeah, I'm just gonna keep with the Generation 4 reactors. You'll see some really exciting stuff like Vogtle right now. They're at like $11,000 per kilowatt installed, and NuScale is trying to keep below like 4,000, which will be really, really competitive. And when you consider the fuel cost for natural gas, so about right now it's about 6 cents per kilowatt hour,
Mm-hmm.
and here in Oregon we're buying it for like 9 cents. And if even the current designs of nuclear reactors, it only costs like 5% of a penny per
Mm-hmm.
kilowatt hour for the fuel. Like it's just so energy dense, and I really truly believe that like his climate change is being recognized. Like there is a lot of drive for it, and
Mm-hmm.
in America, 50% of our clean power comes from nuclear energy, and then number 2 is hydropower, which hydropower is also an amazing technology that works on gravity alone. So
It's just hard out west because you guys have like no water, right? Like at least in California, they have water issues.
mm-hmm.
So you're very optimistic about nuclear. Like you see the field
Mm-hmm.
expanding, I suppose. Have you
Mm-hmm.
ever been to a nuclear power plant? Do they take you around and you get to see, like, check it out, walk around? What's that like?
Yeah, so I've actually been to two nuclear power plants, no commercial ones, but at Oregon State we have a research reactor. Most people don't know that, but there's a ton of research reactors, and I believe there's 50 research reactors in the United States or somewhere around there. And it's just a 1 megawatt. What we do is irradiate samples and do just a ton of research. It doesn't produce any power. But also I went to PNNL with Hanford. I don't know if you've ever heard of that, but that's where
No.
we actually produced all the plutonium for the nuclear weapons that went and got delivered to Japan way back in the day. And it's been long shut down, but they showed us the whole thing, and you can go around and tour it. And it was kind of amazing because back in the day that was a super huge, like super secret project, and now they just do like museum tours of it. And so it's really interesting to see like the technology and stuff.
Yeah, that is interesting. Huh.
But I've never done like a commercial nuclear power plant per se.
I'm not even sure what they even let you in. Do you?
They do tours. They do.
They do tours? Okay.
Mhm.
Huh. So I guess, yeah. Let's see what else I got. Oh yeah, have you seen the popular HBO series Chernobyl yet? Or not yet?
So actually, it's on my list of things to do, but
Yeah.
a lot of my friends have seen it, and a lot of the like radiation health physicists at my work, they say it's pretty accurate. Which, I mean, if you think about like a radiation burn, I don't know, have you ever been sunburnt?
Plenty of times. was
Yeah.
scuba diving in my worst burn. I was scuba diving at the Great Barrier Reef, and there's a giant ozone hole above it.
Hmm.
Didn't put on enough sunblock, and whew, that was terrible.
Right. So like a lot of critics said like that was a really good depiction of what radiation damage is like. I haven't actually seen it, but if you think of radiation burns, that's like the sun is a nuclear reactor, right?
Yeah.
And it will burn your skin, and that's just because it's UV light or anything higher than a UV light. And X-ray will do the same thing if left on too long. And so right, you got to limit your time. You got to put on shielding,
Mm-hmm.
and then just try and stand as far away from it as you can with radiation. And those three things are the most fundamental thing to a radiation health physicist.
Gotcha.
So right, yeah.
But yeah, I totally recommend that series. I think it already on IMDb, it's one of the highest rated series in television.
Awesome.
It was just shot really well.
Mm-hmm.
Made me go on YouTube and check out. I guess there's drones flying over Pre-Pat and driving. It's very apocalyptic. It's, you'll see like a random shoe on the ground. It's kind of spooky.
Mm-hmm. Well, since then, like Chernobyl now has like 100-year cask on it. So, and they're disassembling the core and they're chopping it up and trying to get it in the ground in steel containers or lead containers or whatever they're doing. But that was like even that is like a nuclear engineer's game, right? That's more jobs, and it's a well-paying job. And
it's so interesting to me that Ukraine had such a different reaction to their accident versus Japan. Japan is just they shut down all their nuclear power plants. They're just building coal power plants. Ukraine has some of the highest. Yeah, they produce a lot of nuclear energy still, and they weren't discouraged by it at all.
I think for them, kind of what the story has been told to us is that the Soviet Union, it was the Soviet Union's reactor, and it was a really unsafe design. And they were doing Ukraine at the time, that was their only source of power. And even at that was intermittent power. So, they would take turns sharing the power. And, there's a lot of respect for that. And then on top of that, you had people doing like weapons tests and like just shutting it down really hard, seeing how hard they could drive like the diesel generators on it until one person did exactly what they're supposed to, and they just hit the scram button, and there's a little piece of graphite on the end of a control rod. And
that's exactly what happened in the show. Yeah,
and it went prompt critical is what they call it, and that's bomb physics. which is
okay.
Yeah, by no means what America, like that specific design is banned from America.
Yeah.
Like when ours heat up, the reactivity goes down. So actually one of the exercises that they did with our reactor is they shoot one of the control rods out and it goes prompt critical, but the physics, the fuel heats up, the water heats up, and then it all expands. And then kind of how the physics work is you can't slow the neutrons down anymore because there's not enough moderator or just water. And if you can't slow down the neutrons, you can't keep a chain reaction going. And so the reaction falls on its face. And so the reactor goes from 1 megawatt up to 4,000 megawatts. So 4 times what a commercial reactor produces. And then back down to less than a megawatt within like milliseconds. And that's just like and then you see like the Shrinkov radiation. I don't know if the show talked about that at all. But
they try to. It's a lot to the layperson. It's pretty confusing, but
yeah.
My
girlfriend's laughing.
Not easy to understand.
My fiance is laughing because I explain all this to her. It's just the blue light. So it's just Shrinkov radiation is just blue light, and it's essentially just the electrons going faster than the speed of light in water, because light actually moves slower through water. It goes about 70% of the speed of light, and the electrons are going faster than that. And so they slow down. The particles have to slow down because you can't go faster than the speed of light. And when they're slowing down, they give off that blue light. They give off their energy as shrink-off radiation, which was predicted by a scientist named Shrink-off.
Okay. Russian scientist. Yeah, a lot of really smart Russian mathematicians. If someone's interested in becoming a nuclear engineer, what are the best places to go? Like maybe like a subreddit, maybe what are your favorite, I don't know, if there's YouTube channels, Instagram, anything like that you know about?
Yeah, it's a really old science. Like, well, if you have a nuclear reactor nearby, I would try and schedule a tour with them. But
I had no idea that they do tours. That's really interesting.
If you don't have the chance of going to a nuclear reactor, like there's a lot of books on it. There's not much YouTube videos, which is like a
there's really not
gap in the market.
Yeah,
I would say. So I'm trying to like fill that gap personally. And then I think just like go to college for it almost, or try and find a college with a reactor and ask about it. That like I know our college gives tours. I'm not like representing my college.
Of course not. Yeah.
So
you're your own free agent. Yeah, sure.
Yeah, we give tours on like Mother's Day weekend, which is like really fun for like all the families to come out and see what we're doing. I would follow like the Department of Energy Nuclear Engineering Department on Facebook. Like that's a really good thing, or the IAEA, which is the International Atomic Energy Agency. It's kind of a mouthful, but I would follow them on Facebook. Like they have some really good videos and stuff explaining the science and just with the IAEAs that really align with climate change. Because, when this science came out, nobody knew about climate change, right? And now climate change is this huge problem. Like back in the day, we just thought it was awesome because it was supposed to be energy too cheap to meter. And now it's like, oh, we got this like great powerful energy source that's no CO2 emissions other than the drying concrete, which is absolutely amazing.
Yeah, it's been around for a long time too.
So those two pages, just the DOE-NE page on Facebook and then the IAEA, and then get a college degree in it. That's like a very thorough way, and they'll guide you to some of the books. Like Duderstadt and Hamilton has the nuclear reactor analysis. It's a 70s book. It's got all the math for it though. Like that's what they taught us. It's straight out of, it's written like a 70s book. And
but it's a lot of math. Yeah. A lot of tough, a lot of hard math.
Right. And most nuclear engineer programs, they require that math when you go through it.
Yeah.
So, and then also there's, if you want to learn about it, you can just get a job as like a nuclear reactor operator if they have a high school education, which is like so valuable. I think the average salary is like $80,000, which is
really
amazing.
I gotta do a video on it then. I gotta check that out.
Yeah, that's amazing for like a high school graduate. So
yeah,
like somebody from Columbia Generating Station, just north of the Columbia River, up in Washington State. She came down and she's getting an education with OSU NSE, and like she's a really strong woman. Like she had a kid in the middle of the program, so she just took a year off and went right back to it, and now she's going to go back to that generating station and have a better job, because
there's not a lot of jobs you can get that pay that much for a high school diploma. And yeah, it's very stable. Yeah.
And for engineering, like it's one of the better paying ones as well.
Yeah, I think it's the fifth most lucrative of the census, or not the census, the Department of Labor. They split engineering into 16 different. They combine a couple. They combine aeronautical and
Hmm.
something else into aerospace. But yeah, of the 16, nuclear engineers are the fifth highest paid.
Right. And I would encourage, like, if you share this with your viewers, like, really strongly consider this profession, because honestly, like, if me and a mechanical engineer were to apply for NASA, um, NASA deals with so much radiation that they need so many nuclear engineers, and there's not very many of us. Whereas mechanical engineers, they're like,
There's a lot of them. It's in
they're
one of the big
just neck
three.
to neck. Yeah, like,
The three most populated, it's like civil, industrial, mechanical. Like there's like 300,000 of those
mhm.
guys. Nuclear
And
engineering,
like
it's like very like 18,000.
in the cross sections, like the cross sectional like opportunities, like the intersectionality, like, one of my peers, she's working in like radiation in concrete, like
Mm-hmm.
different kinds of concrete, just like researching that. And that's like a civil engineer with like that needed a nuclear engineer to help. So there's just tons of opportunities. Like I'd say like SpaceX, they need radiation experts, because when you're in
SpaceX, yeah,
space,
that'd be
like
cool.
like I don't know, they're looking, like, they're saying nuclear energy is how we're going to get to Mars, because you can get a reactor, and they just run forever, and they don't need any like hydrocarbon fuels that run out really quickly. So they say we can get to Mars 30% quicker if we use a nuclear reactor, and they get like the high enriched, like the really good fuel, because they don't have to worry about proliferation or anything like that.
It's interesting. We're like okay with nuclear reactors and submarines and aircraft carriers, but it seems like nowhere else for some reason.
Yeah, the military has a lot of, well, I mean, when nuclear energy was first a thing, really who was extremely excited was just the opportunity to have a submarine, right? Because, one thing that you need for like a diesel generator or anything is oxygen, and there's no oxygen underwater. So the technology before is like you would have a submarine, you pump in a bunch of oxygen into tanks, and then you submerge, you'd run your diesel generators off that. You'd have to capture all of your exhaust. And that's just like a logistical nightmare if you're trying to like keep sunk without
And they're
exposing.
running on batteries, apparently. You have to surface a lot more often. It's terrible, like from a military perspective. Like nuclear is obviously
Yeah.
much superior. I think they
Mhm.
decommissioned the last diesel sub, and it might have been like the 70s. It's been a
Yeah.
while, I think, since there's been a diesel powered sub or even I guess diesel powered aircraft carrier. I think the last one for that was 2000s. I don't know if it was diesel or something else.
Yeah. So
Yeah.
so the Navy started doing that with their submarines, and then they're like, oh, why don't we do this for our aircraft carriers too? And so now they have new 2 plans per aircraft carrier. And the Russians, like, what the heck do you do with an icebreaker that runs out of fuel in the middle of like the Arctic or something, where the only way to ship fuel out to them would be to get another icebreaker out there and then pump in more diesel. Like like icebreakers was the other like huge advantage. But those reactors, like the new naval reactors, like they run for 70 years, but that's on really highly enriched fuel, which they only trust the Navy with, because you also have nukes on the submarines. So it's like if somebody steals a submarine, like you don't have to worry about the fuel as much as the other things are ready to go.
Different priority. That's pretty interesting.
And then yeah, like and there's just so much more than just like normal fission reactions too. Like Mars, like the Mars rover is one example. They have radiothermonuclide generators, radionuclide thermal generators, RTGs. And basically all that is it's like decaying polonium-210, and it just produces a ton of heat, like 870 watts per gram, which is like this much. And it's just a powerhouse. Like the old the old rover ran on solar panels, and when they would get dusty, like they would just shut it off until a tornado hit it, and then the tornado dusted off the solar panel. So just that like energy's so useful, and like that's more job opportunities for nuclear reactor or nuclear engineers. So
Yeah, I didn't know that about the Mars rover. That's
yeah.
huh.
And every single like satellite has an RTG on it. It's like it's a pretty standard design, and like also like I don't know for sure, but like intelligence communities use it for like, you know, antennas way out in the middle of nowhere that they don't want people touching. For, you know, you don't want to have to go out to like Antarctica every single month and fill up the gas can, you know.
Right.
So
cool. Well, thanks, Mac. I think that's all the questions I have. Thanks for like doing the interview. Really appreciate it. Maybe like even in a year or two, we could do another one, and just you can update us on your journey as a nuclear engineer.
oh yeah.
And yeah, what you think about, I guess, the world in 2 years. Mac also wanted to let viewers know that it's actually pretty challenging for international students to enter the industry. Many jobs require a U.S. citizenship. So if you have an H-1B visa or a green card, you're still locked out of many jobs in the industry. For more information, I put some links below in the description. Also, for more information on the job and salary market, I have a separate video on this. I go into the salaries of nuclear engineers over the past 20 years, as well as the job market. Are you interested in becoming a nuclear engineer? Let me know in the comments below. Thanks for watching, and I will see you next time.